All right, we're recording. So we are doing module 11, which is investigation of email crimes. We're going to talk about email systems, understanding the components involved in email communication, understanding the parts of an email message, and then overview of email crime investigation and its steps. So it's just a two-step, which is not really surprising. Understanding email basics and then email crime investigations and its steps. So introduction to an email system. So email systems encompass the servers that send and receive emails on the network, along with the email clients that allow users to view and compose messages. Email systems are based on a client-server architecture. The mail is sent from the client to a central server, which then reroutes the mail to its intended destination. So here are our components involved in email communication. Mail user agent. This is also known as an email client. This is an application that enables your users to read, compose, and send emails from their configured email addresses. There are two commonly used clients. There's what's called a standalone. Those are those ones that are typically installed on your hardware, like Microsoft Outlook and Mozilla Thunderbird, or web-based like Gmail, Yahoo, AOL, Mail, etc. And then there's an MTA, or a mail transfer agent. It's also known as your mail server, that accepts the email messages from the sender and routes them to their destination. Examples include SendMail, Exim, and Postfix. And then mail delivery agents, or MDA, is an application responsible for receiving an email message from the MTA and storing it in the mailbox of the recipient. And examples include Dovecot. So there's some different parts or different pieces that you can have here. You can have an SMTP server, POP3, or IMAP. Most of them are IMAP now, but you do have the possibility of running into the others. So SMTP is your simple mail transfer protocol, outgoing mail server that allows users to send emails to valid email addresses. When a user sends an email, the sender's host SMTP server interacts with the receiver's host SMTP server. And this is, whenever you see that port 25, that's an SMTP server that's listening on that. POP3, Post Office Protocol version 3. This one I have seen the least in the last 10 years. It's an internet protocol that it's used to retrieve emails from a mail server, handles incoming mails, and listens on port 110. POP3 automatically downloads emails to the user's hard disk and then removes them from the mail server. And then there's the IMAP server, which is Internet Message Access Protocol. It's an internet protocol designed for accessing email on a mail server. By default, IMAP servers listen on port 143, and IMAP over SSL listens on port 993. This protocol keeps emails on the server even after the user has already downloaded them, thus enabling the user to use multiple devices to check email, which is why you see IMAP more than the other two. So I don't imagine this is new to anybody, but how does your email communication work? This is an example. This is a typical flow of email. You have your user agent. It goes through, in this case, it's SMTP, going through the MTA. Then you have a mail delivery agent, and it goes over to the other person that they're delivering it to. Before I go on to this, when we're talking about email servers, don't forget there are two different types of email servers. You have what are called on-prem or on-premises, and those are on your own servers, and you deal with everything. You set them up, you deal with the storage, all of that. And then there's in the cloud ones. usually things like Google, and that is you are basically purchasing the cloud stuff, and everything stays in the cloud. And those are just your two kind of basic versions of those. All right, understanding parts of an email message. So we have our header, and headers are actually quite important because people don't pay attention to them. But when you go and look at headers, sometimes you can get in and look at metadata that's in a header, and you can get a lot of information on it. And this one, this email header contains information about the email origin, like the address from where it came, the routing, time of message, and subject line. And then you have things like your to CC, BC, your reply to, and all that stuff there. Your body, this is where your text comes in, either plain text, HTML, images, hyperlinks, things like that. And then you have a signature, which, you know, can be just about anything, but looking at signatures and how people sign their emails is also an indicator to help us as cybersecurity professionals, because spoofed signatures sometimes, especially when you use mass spam, will have certain errors and things like that in them that you can pick up and go, hey, yep, this is definitely a piece of spam or phishing email. So how do we investigate these? So email crime investigation involves examination of the origin and content of the email message as evidence. This enables investigators to identify the type of email fraud performed, the criminal and their malicious intent. Crimes committed by sender emails, we have spamming, mail bombing, phishing, and mail storms. Crimes supported by email, identity fraud, child porn, cyber stalking, and child abduction. There are lots of different categories in here, but these are just some of the largest ones. So what are the steps to investigate your email crime? Seizing the computer and email accounts. Excuse me. If it's an IMAP one, you may not be able to seize a computer, but you might be able to go in and get a warrant to get the stuff off the server. Acquire email data, examine your messages, retrieve your headers, analyze your headers, and then recovering deleted email messages. So step one, seizing the computer and email accounts. On this, you do have to obtain a search warrant that should include permission to perform on-site examination of the suspect's computer and email server used to send the emails under investigation. Seize all computer and email accounts suspected to be involved in the crime. The reason they say that is because oftentimes when you're dealing with crimes like this, you have multiple computers and multiple email accounts. So it's better to have a wider scope than it is to say, we think it's this one thing in this one place, and then have to constantly amend your warrant. You can seize the email accounts by changing the existing password of the email account, either by asking the suspect his or her password, or you can obtain it from the mail server. That can be a nightmare in and of itself, but usually if you have an official warrant, that does move things along much faster. Acquiring email data. The next step is in an email crime investigation is to acquire email data for forensic analysis. Before acquiring email data, the investigator should consider the following scenario. Suspect accesses his or her email via any desktop-based email client. Suspect has a web-based email account on which the crime has occurred. Email data acquisition methods would be different for each scenario. So, why do you think they would be different? The desktop versus web-based email.
Because one's on a cloud and one's actually there. So they should have the files on the actual hard drive and whatnot.
Yeah, for one that's, if you have the actual desktop-based client, and you manage to get the physical device, you can image the drive, and you can do it that way. But if it's all web and cloud-based, that is significantly different. Exactly, personal versus public storage, and then you have to deal with whatever server that is stored on, which can be an additional headache for your warrant. Acquiring email from desktop-based email clients. When an email crime is suspected to have occurred on a user's machine using email clients, the key source of evidence are local folders and archive folders stored by the programs that hold information regarding email activities. Forensic investigators need to locate the local folders and recover the email messages using the right forensic tools for further examination. While acquiring email data from local archives, investigators must be careful to gather all the files, as local archives can be split into multiple files that store data separately. So I'm going to give you an example. Because the last couple of places I've worked had different storage on the server requirements. They, like, the one place had a guaranteed 6 months, but when you have thousands and thousands of users, after a shortened period of time, you have to tell people they need to be responsible for their own storage. So they would show people how to create a local archive. And that is a different, they had different storage space for files than they did for emails, because it was a completely different storage thing. So, you had to go and figure out where, and this is from having to go back things up. You had to go figure out where the person stored them. And sorry. Sorry, I didn't want to cough really loud at you guys. But people could store them in any number of places. So, no, I'm sorry, Steve, that's terrible. So usually what we ended up doing was we got really good at figuring out what the extensions were for these, and we would search for like asterisk dot, whatever the extensions were, just so we could be sure we hadn't missed any of those archived files. Okay, Microsoft Outlook. So when users configure their email account on Outlook, it creates a local copy of the email information in two kinds of file formats. There's that PST, or personal storage table, and that has certain kinds of POP accounts that use that to save the mailbox information on a local computer. And then by default, that is the location for that. And then there's the OST, or offline storage table. This is like your Microsoft Exchange, Office 365, IMOP accounts, and they do the OST files, and that is the location of that. So knowing that is great, but sometimes people will take those files and move them around and back them up in different locations. So searching for that extension is also a good way to find additional ones that are moved around on the hard drive. Email artifacts can also be found in the archive folder. That's the one I was just talking about, which is a default folder created by Outlook, along with folders such as inbox, drafts, and sent items. You can see that graphic on the top there. In Outlook 2010, 13, and 16, having an Outlook auto archive feature that enables users to move email messages and other important items to an archive folder. To know the Outlook 2016 auto archive data location on the suspect's machine, and then you see here, this is how you find out where that might be saved. But you can find that there, or you can also look for that PST file format as well. And then there's Thunderbird, which is another local email client. This one saves files with the SysTool Mail Pro Plus. This is what they're talking about using here. Use tools like SysTool Mail Pro Plus to examine local mail files and folders and collect them as evidence. You can select one or more mail mbox file, which is mailbox, or specific local email folders for forensic acquisition and analysis. Mail Pro Plus offers 6 different views to look at the messages extracted from the Thunderbird local folder. Then you can see over here, it has an example of what that looks like. Select all email messages of evidentiary value and click export to acquire them. And then you can select the exported file type and name format and collect the selected email messages in the chosen destination folder. And this one, and unlike user preferences with the less is more, on this one, it's better to grab everything and then whittle down what you need later on. Examining your email messages. While looking at the acquired email messages, you need to closely examine the following areas. Your subject. This field is important as it sums up the message contained in that email. Most spam email subjects create a sense of urgency. Remember how I talked about fear and urgency overriding your common sense? That's what they use to try and prompt the users to open the mail. The sender's email address. Attackers often spoof this address and make it look legitimate to the user. You can see here that customer support team at ABC Bank is using a Gmail account instead of a respective bank domain, which is suspicious. So whenever I taught classes on how to find these, I'm like, okay, if it doesn't say at whatever domain of the place was that I was teaching the class for, this means it's, if it's a Gmail or a Yahoo, or I said, this is not an official account. Email body. A spoofed email body might contain direct links or hyperlinks designed to lure users into providing sensitive details. One thing that I also taught people was the hover over it to see where it's actually sending you, because just because that's what it looks like it says, sometimes you'll hover your mouse over that link and find out, oh, that's not actually where it's sending me, which is very common for these types of messages. Email attachments. Attackers can embed malicious JavaScript, Visual Basics, or exe files within your documents and PDFs sent as attachments. You need to examine the attachments within a controlled forensic environment. A lot of times they have a forensic computer that is completely unhooked from the network so that they can check out things like this. A question? Oh, no. Another indicator that you'll see that's not listed here, that's used a lot of times, you'll see a banner that's on there that says this email is from an outside organization. That's something that a lot of places have taken to doing because it's literally just smack across the top of the email that says this is not from an internal email address, because that gives them another added thing that says, hey, maybe this might not be a legitimate email. Retrieving email headers. If an offending email has been identified or is suspected to be spoofed, investigators must examine its header information. The email header plays a vital role in forensic investigation as it holds detailed information on the email's origin, which can help investigators gather supporting evidence and identify the culprit behind the crime. Email header information can be retrieved after acquiring your email messages. If the investigator is physically accessing the suspect's computer, they can view the email header using the same email program as the one used by the suspect. This process is, of course, different for different email programs. So what does this look like with Microsoft Outlook? So this one is Microsoft Outlook 2016. You launch MS Outlook, double click on the email message, click the file button, which is on the top left. Then go to the properties icon. You can see they highlighted it here. And then when the properties window opens, select message header text from internet header box, then copy and paste the text into any text editor and save the file. The reason they say that is, I don't know if you can see here, that little tiny square they have there. Well, there's also a ton of more information there. So it's just easier to dump everything into a text editor and actually open it up so you can see all of it. Okay, so how does it differ in Microsoft Outlook.com? Looking for this on Microsoft Outlook.com, or you log in and select the received mail for which you want to see the headers. Click on More Actions, drop down button, and navigate to the View Message Details option, which is down there on the bottom. Select the message headers text from the message details box, and again, copy and paste it into a text editor and save the file. As you can see, you can have a ton of information here. Gmail. Most of you should have a Gmail account or some experience with Gmail. So this is how you do this for Gmail. Log on to Gmail, and I suggest you go in and just to see this for yourself, open up your Gmail account, click on everybody has a spam folder in there. Pick on a random sales advert and do this. So go into Gmail, select your received mail for which you would like to see the header, click on the More drop-down button, and navigate to the Show Original option. Select the message headers text, copy and paste into any text editor, and then save your file. And you can see down here, we have a whole bunch of stuff here that you can see on that. All right, so now that you know how to get in and get that information, how do you analyze your email headers? Honestly, analyzing email headers, it sounds kind of dorky, but it's a lot of fun because to me, it's like sifting through information for a jigsaw puzzle. So what are you looking at? Okay, on this one, they've been really nice and like parsed out everything with numbers. So on this one, the first one, number one there's our date and time when the mail was sent. Number two is the from. It shows the email ID of the sender as it is visible to the recipient. This can be forged in the case of spam emails. I will say one of the things that I've seen on the from, it'll say the name, and then you'll see a bunch of like gobbledygook, and they've said like George Smith, and then they say the email, and then if you look the actual email in the brackets, because they try to make people think, oh, that's the email, when really it's just that they put a fake email in where the name section is. And then if you look at the email in the brackets, where like where the Yahoo one is on this one, you go, oh, okay, this is just a low-key attempt at hiding their email. 3 shows the to line, which is the email ID of the recipient. 4, this is your message ID. As per RFC 282, a specific email message should have a globally unique message identifier. The first part of the message ID before the @ contains the timestamp, and you can see here, of the email in Unix epoch format. You can see how That number converts to that in here. And if you don't know, you can go out and type in Unix epoch converter, and there's calculators and all sorts of stuff out there. Part of the message after the at contains fully qualified domain name. Here the domain name is mail.yahoo.com. You know, but usually we only see like yahoo.com or gmail.com, but we'll see the whole qualified one there. 5 is the subject, and it shows the subject as given by the person who sent it. Then 6 shows on this one, this is the MIME version. Multi-purpose internet mail extensions are used to support non-text attachments like video, images, and audio, and the default is 1, version 1.0. All right, next down here, we have the received header. The entries in the received headers are of significant forensic value, as these cannot be forged, unlike other email header elements. The number of received headers found in an email message depends on the mail servers that process the message as it traveled from source to destination. Investigators should start with the bottom-most received header, and you can see down here it has a little blue B next to it, as it is closest to the source, and then move towards the top. So sometimes if you have a bunch of hops, you'll see multiples of these. So start at the bottom and move up to trace backwards. So here the header B is shown the domain name for the email message origination. You can see this here, and the associated IP address and the date and time. Okay, so next we have our return path. It is the bounce address for the emails that are sent but not delivered to the recipient. If the sender's email address and the return path address are different, it generally indicates email spoofing. Received SPF, this is your sender policy framework, or SPF, refers to the process that enables organizations to mention servers that can send emails on behalf of their domains. An email header showing a failed SPF check can help detect spam messages. So if you look down here, if you have your return path and it's different, that'll be like, okay, that's a bit of a red flag. And then if you look down in 9, received pass, and it was permitted, so this was permitted to come through. You'll see on there rejected and things like that if it's not, if it was not gone through correctly. Domain keys identified mail or DKIM signatures. This offers a cryptographic way of verifying whether a received email has actually originated from the sending domain. There are different elements of the DKIM signature that they branch out to here. So V, this field stands for the DKIM signature version, which should always be set to 1. A field shows your algorithm, so that's like SHA-256, SHA-1. It better not be SHA-1. Hopefully you should see SHA-256 or 512, because if you see an MD5, that's very, very bad. C, this denotes the canonical algorithm used. It shows if there is any modification in the email in terms of white space or line wrapping. The first value before the slash is for the header and the rest is for the body. D field refers to the domain of the sender. On this one's Yahoo. S refers to the selector to identify the DNS public key. You can see that listed there. T field denotes the timestamp. And remember, that's that set of numbers that you'll have to go and get translated. It uses that Unix epoch time and should always match or be close to the time reflected in the received header and message ID fields. Sometimes it might be a few seconds off if you have a whole bunch of hops, if you have like a high security server it's going through. Sometimes it'll be a couple of seconds off, but it shouldn't be like 20 minutes off or something like that, because that's an indicator that that's way too much. BH field is the hash for the body as per the hashing algorithm in use, and then encoded is base 64. And then B field includes the DKIM signature that should be calculated as per the header field mentioned in the H field. So don't be upset if you can't remember all these. This is one of those slides that, I mean, this is one of those that I can't remember all of them for. Sometimes I have to go look up, oh yeah, what was that? Which one was that it stood, you know, but this is a really good one. If you want them all in one location, you can swipe this one. Okay, checking email authenticity. Once the sender's email address has been identified, investigators should check whether it's valid. You can use Email Dossier, a scanning tool included in CentralOps.net suite of online network utilities. This tool provides information about email address, including the mail exchange records. It initiates SMTP sessions to check address acceptance, but it never actually sends your email. There's some other ones you can use here. Email address verifier, email checker, and GLock software email verifier. And then you can look at what Email Dossier looks like over here. So it just kind of shows you what it would look like if it was valid. And if it's not valid, my guess would be where it's green down here, you probably get like some red or something like that. All right. Investigating a suspicious email. So let's examine the email message. This message invokes a sense of urgency. So we talked about that. Asking the recipient to log into their Twitter account. Inspect the message body thoroughly and look for any suspicious links or attachments. The screenshot below shows a link to Twitter login page, which is linked to the private IP address, which you can see down here, 10.0.0.32. So if you want to know if the link is, if there's something wrong, you can check it out. Run the link given the email message on a forensic workstation within a controlled environment. Here you can see the link redirects to a page 10.0.0.32 Explore instead of Windows login page, which definitely should tell you, oh, hey, this is not a legitimate email. Next, analyze received header entries. So remember how we talked about starting from the bottommost, received header entry, and then go up top to locate the email ID and IP address from the attacker. Here, the highlighted received header entry shows the message originated from a website called emkei.cz with that IP address, which strongly indicates email spoofing. Examine. My guess is that, yeah, they aren't showing you the whole thing. You're just getting, this is where it was on the list that they were showing. If that was what your question was, Mike.
Oh, no, I was making reference to a rap song.
Oh. That is definitely not my genre, so no, I wouldn't know. Examine the originating IP address. Look for your IP address details collected from and received from header in the "What is my IP address" website. Pardon me. You can see the IP address is registered under the host name. You see that there, for an organization called Liberty Global, and they are in Czechoslovakia, or whatever they've got listed here. Usually when you see things like this, it's a pretty good indicator that this is not legitimate. Examine the received SPF field. Analyze the received SPF header to see if there's any SPF validation failure. You can see that the received SPF field below is showing a soft fail, which indicates the domain of josereagan@gmail.com, or the sender does not permit the server, which is listed there, to send mails on its behalf. This validation failure is a sign that the message might have been spoofed. So remember how before it had that it went through? Anything that indicates something like that is so that was a good comment, Mike. Anything that has anything other than, that it passes through is something you should investigate. Checking your sender's email validity. Use the email dossier that they talked about website to see whether the sender's email address as shown in the email message is legit. You can see email dossier shows the email address to be valid. This indicates the attacker might have compromised that email account of a user named Jose Reagan, or obtained the email address via social engineering techniques. Examine the message ID. You can see here the highlighted part of the message ID shows a fully qualified domain, or FQDN, that to be the local host instead of a mail@gmail.com, which clearly indicates that this is a spoofed email message. All right, recovering deleted messages. So recovery of deleted email messages depends upon your email clients that were used to send the mail. Thunderbird messages deleted from the mailbox reside in the trash folder until it's cleared. Some forensic tools might recover these deleted messages depending on how soon recovery is attempted. Email messages deleted from the trash section of local folders can be completely recovered. Then there's Outlook. When email messages are deleted on Outlook, they are moved to the deleted items folder. If the emails are deleted from the deleted items folder, they will go to unallocated space of the drive. The deleted email messages can be recovered if the unallocated space has not been replaced with new data. So as long as they haven't been overwritten by something else. You can use Parabin's electronic evidence examiner tool to retrieve and collect deleted email messages from Outlook and Thunderbird email clients. Recovering deleted email messages from Outlook PST files using, this is the Parabin electronic evidence examiner they were just talking about. Here, the screenshot shows the retrieval of 2 messages by Parabin that have been deleted from the local PST files. You can see the recovered email body attachments and the RFC headers and use the information for further analysis. So you can see the program here, and then you can see the things that they've got circled in red that they were able to pull out of the deletion. Okay, so what did we talk about? Email systems, email servers, different components of email communication, the parts of an email message, detailed discussion on email crime and investigation and their steps. In the next one, we will talk about malware forensics. Are there any questions about email or email spoofing or anything like that? Okay, that is legitimately funny because that's one of my favorite Star Wars spoofs, German. But are there any questions on emails or email crime that anyone might might have? Sorry, my throat's been really dry today. Okay. So, like I said, stick around because tomorrow is the other class. Friday, when we get together, we will be working on let's see, autopsy. So my suggestion is autopsy takes a while to download. My suggestion is to go out to additional resources, and it's literally right here at the top. This one right here at the top is the one for Windows. It's a downloads an MSI file. And you just double click it and run it. I will tell you the first thing that my computer did was Windows went, because it's a forensics tool. And I just said, it's fine, go ahead and install it. And I took all of the defaults, and I suggest that you do that now before Friday if you would like to follow along, because you will be able to have more back and forth and talking about stuff, because there's a lot of functions on autopsy that you are going to want to learn how to use. Yeah, you've seen autopsy a few times, I'm sure, from CyberQ. And we're going to use one of the case files, and I'll put that out there. That's what we're going to use as some stuff for next week. But I want you guys to get familiar with the tool. So I would like you to download that, and we're going to work with that on Friday. Okay. So here's how you do that. Windows right here, Linux and OS X on the second part here. So please make sure to get that downloaded and installed before Friday. If you would like to have the ability to follow along and actually go back and forth with me and talk to stuff while we do things together. Okay. All right. I'm going to go ahead and stop the recording here, and we will talk about homework.